Hello everyone, this is Prashanth. Let's continue with the last lecture. So in the last lecture, just I completed about the use cases, real-time examples, advantages, disadvantages, main block diagram, what are the real functions of XMPP, Extensible Messaging Presence Protocol, XMPP, Extensible Messaging presence protocol. So that is the completed in the last lecture. So now I'm going to introduce another protocol which is available in the application layer, that is AMQP. AMQP stands for Advanced Message Queuing Protocol. Just we have to maintain one queue format while sending the information from the sender. So it is the, just we already know, under we are in application layer. Under application layer we have different protocols like HTTP, COAP, WebSockets. Just we are using right now topic are AMQP, Advanced Messaging Queuing Protocol. So in transport layer you are having different protocols, network layer having different protocols, IPv6, IPv4, 6LO, WPAN, like that, and link layer also having like 802 series protocol, Ethernet to WiMAX, 2G, 3G, LTE, long-term evolution protocol, and Wi-Fi, LR, WPAN, like that. We have different protocols under application layer. But our agenda is to, in order to distribute the, discuss about the application layer. So it defines how the application can interface with the lower protocol and send over the network, we already know. So here our agenda is AMQP, Advanced Messaging, AMQP, Advanced Message Queuing Protocol, Advanced Messaging Queuing Protocol. So here application enables process to process. So these are the some elaboration of these points: HTTP, COAP, WebSocket, MQTT. So HTTP, Hypertext Transfer Protocol, it is the foundation of World Wide Web. So COAP, Constrained Application Protocol for machine-to-machine applications with the constrained devices. And WebSocket, it allows full duplex communication over a single socket connection. And message queuing telemetry transport. It follows the publish to subscribe communication model, which uses the client server architecture. So these are the four elaboration. And XMPP, DDS, data distribution service, and AMQP. So here AMQP stands for, we already know, Advanced Message Queuing Protocol, very very important. Right now I am going to explain about this one. Is a open application layer protocol for business messaging. To do the business, just you can main application of AMQP is business messaging, supports both point to point and publish subscribe communication model. So this is the main introduction point of AMQP, Advanced Messaging Queuing Protocol. So here what is AMQP, what is the main specifications of AMQP here? AMQP used for advanced messaging, Advanced Message Queuing Protocol. This is AMQP. It is a protocol that is used for communication between the applications, and it is a lightweight protocol that supports applications for data transfer. This is protocol used for the its scalability and modularity with the latest technologies. So this is the main aim of Advanced Message Queuing Protocol. It is used for its again repeat scalability and modularity with the latest technology. So this is the just diagram of AMQP here. It start with the publishers. Publisher message to the exchange. It is exchange of information from queues. This is Q1 and Q2. So here the route message based on the binding 1. Route message based on the binding 2. So here the queue, subscribe to the queue and send message to the consumer, request message and send the message, request and send the message to the consumer. So this is the the way of working process from publisher to this subscriber with the help of queues in the middle of the block diagram. So this is the what AMQP advanced message queuing protocol. So it is the best used for improve the scalability and modularity attached with the latest technologies, advanced messaging queuing protocol. Next, a brief history of AMQP here. AMQP is an open standard application protocol layer utilizing binary. Its purpose to enable fast and efficient communication between the message oriented middle services. So it is the develop the message oriented middleware services. Middleware services. It is the fast, enable, and efficient communication between the message-oriented middleware services. So here, believe it or not, AMQP was actually first conceived, but not in industrial automation circles, but within finance in 2003. John O'Hara developed AMQP at JP Morgan Chase, the global US financial institution. So it is not in the network first developed. So it is developed through the financial institutions only. From the get-go, AMQP was designed to be an open collaborative effort. JP Morgan initially led a lot of the development work upon until 2006. So at which point the back approached large technology institutions, Red Hat, Cisco system, and Microsoft to form a cooperative working group. So with the help of these, they are companies working together to develop the advanced message queuing protocol. So this is the some basic introduction point, history points of AMQP in order to develop the message-oriented middleware services. So the components of AMQP basically exchanges, channel, message queue, binding, virtual host. So what is exchanges? So the exchange is responsible for fetching messages and properly arranging them in the appropriate queue. That is the exchanges. And channel. A channel is a multiplex virtual connection between the AMQP peers that is built into an existing connection. So that is about the channel. The third one, message queue. It is a unique entity that connects messages to their resources or points. That is message queue. And binding. So binding are set of predetermined instructions for queuing and exchanging. It manages the message transmission and delivery. So that is the binding. The last one, virtual host. The vHost is a platform that provides isolation capabilities within the broker. Multiple vHost may be functional at the same time, depending on the users and their access rights. So these are the components of AMQP: exchanges, channel, message queue, binding, and vHost, virtual host. So these are the components of AMQP. Next, layers of AMQP here. Here two types of layer, function layer and transport layer. So this is under only application layer, but in that nested layers like that, function layer and transport layer. Under the function layer, it handles the basic file transfer, transportation, message queues, access and control streaming. So the function layer deals file transfer transactions, message queues, access, control streaming. So here the transport layer can framing content, data representation, and error management. So here the transport layer content of data representation and error management. data error management. So these are the two layers of AMP. And what are the AMQP use cases here? To whenever there is a need for high quality and safety, safe delivery message of between the applications and process, AMQP implementing message brokering solutions can be considered for use cases. So here the use cases for AMQPs are brokers, broking solutions here, broking solution. So here AMQP ensures that what are the brokering solutions, reliability of message deliveries, the first one, rapid and ensured delivery of messages, second one, and message acknowledgement. So the when the receiver it receives the message, it can send the acknowledgement to the sender. Hence, your message is received at receiver. Like that, the ensures reliability of message deliveries. That is the essential thing. And rapid and ensured delivery of messages. The last one, message acknowledgement. Also, it can send to the client. These capabilities make the ideal for these things. Monitoring and globally shared updates. Just it can maintain global entities or global sharing updates, and connecting different systems to talk with each other. That is the second one. And allowing servers to respond to immediate requests quickly and delegate time consuming task for later processing. So that is the third one. And it can ideal for distributing a message to multiple recipients for consumption. That is the fourth one. And it is capable to make ideal for enabling offline clients to fetch data at a later time. And it is ideal for one more, introducing full asynchronous functionality for systems. And it is ideal for increasing reliability and runtime for application deployment. So these are the some things, capabilities to make it ideal for these several things, like monitoring and global sharing updates, connecting different systems and tasks to each other, allowing servers to respond an immediate response request, distributing a message to multiple recipients for consumption, enabling offline clients to fetch data at a later time, introducing fully synchronous functionality for systems, increasing reliability and uptime application deployment, like that. So these are the some real-time use cases of advanced messaging queuing protocol. Assumption, assembly and terminology of AMQP here. Broker is nothing but server, message, consumer and producer. So what is server, what is message, what is consumer, what is producer? Let's see one by one. An application implementing the AMQP model that accepts connections from client for message routing and queuing, etc. Message, the content of data transferred or routing, including information such as payload and message attributes, like that comes under message. The last but one, consumer, an application which receives message put by a producer from queues, and producer, an application which put messages to a queue via exchange. So these are the four assembly and terminology of AMQP, that is broker, message, consumer and producer. And how does AMQP exchange of work here? After receiving message from publishers, that is from the clients, the exchange of process them and route them one or more queues here. The type of routing performed depend on the type of exchange, and there are currently four of them. Direct exchange type involves the delivery of message to the queues based on routing keys. Routing keys can be considered as additional data defined to set where a message will go. This is the direct exchange. Fan out exchange. So here the fan out exchange completely ignores the routing of the key and sends a message to all the queues beyond to it. Use case for fan out exchanges here usually involves distribution of a message to multiple clients for purposes similar to notifications, and sharing of messages and updates here, application status, that is example configuration. So these are the how does AMQP exchange of work with the help of direct exchange and fan out exchange. Here we are having some use case for fan out exchange also, with the help of sharing of message, that is chat server and news application data status also, that is example for configurations of the device. So this is the how does AMQP exchanges works. And remaining total topic exchange and header exchange also. uh, Topic exchange is mainly used for publish subscribe patterns, using this type of transferring a routing key, binding the queue exchanges are used to match and send messages, that is the topic exchange. And whenever a specialized involvement of a consumer is necessarily, um, topic exchanges comes in handy to distribute messages accordingly based on your keys and patterns. So here the last one, exchange of headers. It is constitute of using additional headers coupled with the messages instead of depending on routing key for routing to queues. Being able to use types of data other than strings, header exchange allow differing routing mechanism with more possibilities, but similar to direct exchange through the keys. So these are the some exchange of works: direct exchange, uh, direct exchange, fan out exchange, topic exchange, and headers exchange. These are the four types of exchange methods in to do the performance of AMQP. And key capabilities and business case is here. Some capabilities here. Organizations, applications in different organization, and topology technologies, applications are different platforms. Organization technologies, time systems does not need to be available in simultaneously. Space reliable, operate at a distance or over poor network. So these are the four capabilities of AMQP connect across the global. And in terms of business case, the main reason an enterprise will choose AMQP over proprietary alternatives are realize the saving commodation brings over the vendor lock-in period, connect applications on different platforms, choose the right platform for the job, and connect to business patterns using full featured open standard, remove technical barriers to trades, and position for innovation, build upon the foundations of AMQP also. So these are the some capabilities and business case of the AMQP to develop the IoT application, real-time IoT applications. Connect to the business partner, position for innovation, build upon the foundation of AMQP, realize the saving combination brings, like that we have different business cases. And bottom line here, the capable commoditized multi-vendor communication ecosystem which AMQP enables creates opportunities for commerce and innovation which can transform then way is done on the internet and the cloud. So this is the designed to solve real problems and completely business partners and services here. Just it is the treasury, orders from supply, AMQP aware of softwares, AMQP aware of client. It is the AMQP infrastructure, like that. Based on the different this is my enterprise. Based on that, clients, treasurer, orders from supply.com, and the AMQP aware of system using C, C++ or Java, JMS, MS, WCS cloud applications we have. So this is the bottom line of the advanced message queuing protocol. The last one, just it is AMQP versus MQPP, just comparison. So here MQTT also one of the protocol which I explained in the previous one. It is message protocol designed to facilitate communication between distributed systems. Although the serve a similar purpose, they differ in their underlying principle and use cases. It is AMQP Advanced Message Protocol. It is standard designed for reliable, secure messaging. Open standard simply means that the document that defines the rule of the AMQP protocol is out there for everyone to use. Design AMQP client and applications. Fundamentally, it follows brokered messaging pattern. In pattern, message act as a intermediate between the publisher and subscribers. So AMQP broker is here in the terms of publisher and consumer, with the help of exchange of information from the publisher and consumer. So this is the AMQP broker. So MQ2T broker here also same as like AMQP, but somehow different. This is the MQ2T type. It is follows publish subscribe pattern. MQ2T client and publisher, the topic, publish subscribe for different to MQ2T client. And the similarities of AMQP and MQ2T here. Publish subscribe model, asynchronous messaging, quality of service in order to maintain the quality of service, and financial transaction and MQ2T definition. So these are the similarities: publish subscribe model, asynchronous messaging, quality of service messaging, and use cases in terms of financial transaction only. In the world of finance, the timely, accurate messaging is essential for conducting transactions, managing risk, and disseminating market data. AMQP ensures that messages related to the trades, payments, market updates are reliable, delivered to their intended recipients without any loss. So this is about some use cases of AMQP and MQ2T. So these are some real time in terms of Internet of Things and MQ2T Internet of Things IoT applications also. In terms of Internet of Things is a concept that refers to a network of everyday objects, devices, and sensors that can connect to the Internet of Things and it communicate with each other. For example, imagine being able to control your home's temperature, light, security system from your smartphone, or having an fitness tracker, send data to your doctors for monitoring. So that is the IoT allows for smarter interconnected devices that can enhance our daily lives and improve various aspects such as health, safety, energy efficiency, and productivity. MQ2T and Internet of Things applications. MQ2T is widely used in IoT deployments where devices, sensors, and systems need to exchange data efficiently. So these are some real-time use cases. In summary, choosing the right messaging protocol for your application requires a clear understanding of your requirements. So based on our requirement, just we move to either just we follow the MQ2T or AMQP or COAP like that. AMQP and AMQP, despite the differences, both serve as powerful tools for enabling efficient communication in various scenarios. So these are the differences of AMQP and MQ2T. So here in terms of architecture, working, message scenarios, framing, transactions, security and message discovery, extensible and reliability, implementation, compatibility, and use cases. In terms of different features, just we may differentiate between the AMQP and MQ2T. So it supports client server architecture, client broker architecture, and working with here responsible for processing them. Here the publish subscribe communication model. Message scenario, it follows the AMQP supports various messaging scenarios including publish subscribe messaging scenarios. It is the same. And framing, it defines the framing structure within a messaging protocol. The maximum supported data size in 256 MB only. That is the framing. The transactions, messaging protocol transactions are predefined. That is in AMQP. MQ2T fears future transactions question, then AMQP connected disk and like that. Security and message discovery. Today's interconnected world, security is crucial in messaging system. MQTT leverages TLS profile to authorize the client brokers. Extensible and reliability and implementation compatibility. And in case of use cases, it is both having a wide range commercial applications. MQTT clients are generally small, meaning they can function even with minimal resources. So these are the different resources, references I used for this lecture. AMQP.org website, digitcochlean.com, Geek for Weeks, deployferry.com, like that. We are using different references for this lecture. These are the differences are AMQP, Advanced Message Transfer Queuing Protocol. Everything in with the help of queuing only, we are sending the information from one to another device. So remaining continue with the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.